Okay, good afternoon. My name is Chris Garcia. I'll be one of the presenters today. We're going to be talking about our facility planning term project. This is for engineering class 4375 for facility planning at Charleston State University. So, like I said, I'm one of the presenters. Kyle Fan, he's another presenter, and Michael Bradford, he's our last presenter. So the outline that we'll discuss today is our introduction. What is cellular manufacturing? We'll talk about I cells, we'll talk about U cells. We're going to talk about current process flow and our baseline data. We'll talk about the line layouts and the assumptions. Pros and cons of line and U cell layouts. We'll talk about variables, issues, and risk with changing or staying the same. And we're going to talk about proposed actions. And let's get into it. So, introduction. So, cellular manufacturing is a method used by manufacturers adapted to lean manufacturing processes. Now, this is like companies, oil and gas, automotive, those type of companies. The ease of implementation allows for a high impact to the business without requiring a lot of money up front. So the benefits of this is we're going to have reduced material handling costs, reduced process lead times, decreased machine setup time, reduced work in progress, increased delivery time, and we're going to be able to just have limited inventories on hold. So we'll have good use of our space. So the I cell, so it's commonly used just in short processes from point A to point B, single line, usually just one worker. An issue with this is that it's going to cause the inventory to build up. And a straight line will cause the worker to have to walk from point A to point B, so that could cause fatigue. So talking about U cells, it is in the shape of a U, as the name gives it. Operator can finish their work in the same location that they start, eliminating the walking distance to the end of the line. Process flow in the counterclockwise rotation. Operation flexibility to scale up or down depending on the demand. We can provide convenient foundation of one-piece flow. And my colleague will talk about the current state process data. Michael Bradford.
Thank you, Chris. So we're going to discuss the current process data. So our current process layout is a straight line with 7 workers. The assumptions are listed here. There's 8 hours in a day. The line produces a product every 9 hours for product A. For product B, it takes 4.5 hours to finish. So this is our current process data. So for product A, it produces 250 parts annually and 22 pieces a month because it only produces 1 part per day. On product B, there's annual products of 625, with monthly being 55, and this process allows for 2.5 parts per day. So this is the operating loading. The current Part A current operation chart is very unbalanced, and with a takt time of 7.25 hours. And you can also see that product B is also very unbalanced, with a total takt time of 3.9 hours. So our current state baseline shows that in the outline, it takes up 270 square feet for the product line. And the crew station has 7 workers. There's also 7 workstations. So at an annual labor cost of $7.25 per hour, both product A and product B have a total yearly cost of $105,000. So this is some opportunities we can have by going to a U-shaped cellular layout. Inventory, waiting, motion, transportation, and overall production. So now we'll turn over to the future state and we'll let Chris and Kyle finish up for us.
All right, good evening. I'll take over the last part of the presentation. I'll to present the future state. So in the future state cell layout, this is how it looked like for A and B on the U-shaped cell layout. So in the U cell layout feature state, product A, operator loading chart will be more balanced between the processes, and we combine the processes that currently we have to the workstations, which is 3 workstations for product A and the same for product B. Here's some pros and cons between the I cells and the U cells. Here's some highlights, which is in the U cells volume flexibility, which is we flexible scale up and down within the cell, and then the operator have ability to operate multiple processes within the cells. And the pros of the I cell is just easy to implement for the short production processes. The cons, I cell had more cons than U cells, which is the cons of the I cells is harder to communicate among operators within the work cells, and accumulate and stack inventory, potential of hidden quality issues that we never get to know until the product is finished. And the cons for the U cells is just requires devices and tools and more materials inside of outside of the process or conveyor per se. And material replenishment in the U cell is not easy. It's required a Kanban system and replenishment strategy that would have to be done afterward. Here's the U cells assumption. Some of them is we link the processes together. We implement the one-piece flow concept. From here, we're gonna see divided by 3 workstation. Currently, process 1, 2, and 3. Station 1, 4 and 5, station 2, and 6 and 7 is station 3. And operator will cross trains in each process so you can move them around, and then they can rotate during their process. And the same for product B, we'll do the same, which is process 1, 2, and 3, station 1, process 4 by itself because it takes a longer time to finish. 5, 6, 7 is station 3 and produce 1 part every 1.5 hours. Here's the layout flow results between straight line, product A and B, U-shape, and total changes that we made, improvement. So on the inventory, we reduce from 7 jobs to 1 jobs and 86% improvement. Process times from 9 hours from the current state for product A, 44.5 hours for product B. We reduce to 3 hours for product A with the U-shaped cell layout and 1.5 hours for product B. And that gives us a 66% of improvement. So the productivity before is 0.14 for product A, 0.34 for product B, and after change it, we improve 50%, which is 0.28 and 0.69 for product B. So here's some highlights of improvement, and some of the improvement is really significant. As you see, inventory is 86%, and then process time is 66%, or productivity is 50%. Here's some of the requirements and implementation plan if we decide that we go into the U-shaped layout. We need to do all the requirements to move in the cells and change the layouts, all kinds of electrical works, tooling and fixtures, moving the machines, all kinds of that. It gives us to estimated $18,000. And that is implementation plan, which is what we have to do first, and after that to finish up the U-cell layout. And here is some return on investment. Based on the cost of $18,000 of implementation that we present earlier, the labor saving as we present as improved 50%, which is we saving $60,000 every year, and give us that 0.3 years to pay back if we go ahead and implement this U-cell layout today. And other benefits of the U-cell layout implementation is reduce 50% of lead times, reduce 57% of labor costs, increase 50% of productivity, reduce 43% of headcounts, and significant improvement in process inventory. Issues and risk. There were some issues and risks we might run into when we implement U-cells. So if we want to run more U-cells in the manufacturing, we have to add another U-cells. It's hard to expand. Potential of limit points of use in storage, because right now we have the process flow faster. We produce the part faster. We have to look into the calculation of how we replenish material in and out of the cells to make it easier. So that require another workshop or project to take care of that later on. But it's easy to accomplish. And new process training may affect production because of the time's requirement to train operate to use the new process and layout and the way that we operate within the U cells and one piece flow. Our team will recommend our manufacturing implement U cells layout in our manufacturing because of the improvement of the U cells as shown above, and because of the significant improvement, we would like to recommend our executive team to make the decision on this project and move forward. If you have different question answer, or want to answer or concern, or any comments about this project, please contact us as this email below. Myself or Michael or Chris. We thank you for your time here today with us, and we appreciate your time. Listen to our presentation. Thank you.